Welcome to our day 21 lesson. This is a lesson about the law of sines and one example problem that we had. So in this case we had a hill, kind of demonstrated, diagram by this picture here, a hill rising at a constant rate of constant angle of elevation of 23 degrees above the horizontal. So we've got a horizontal line going across the bottom of the image and then a 23-degree angle. So then the hill is going up this diagonal slope. There's an 80-foot vertical flagpole at the top of the hill. So from the tip top of the hill up to the top of the flagpole is 80 feet, as demonstrated in the diagram. There's a 30-degree angle between the wire and the hill. There's a guide wire from the top of the flagpole down to point P on the hill. There's a 30-degree angle here. Our question is, what is the length of that wire? So in order to solve that problem, we're going to be trying to apply some ideas of trigonometry. First thing that we'll do is drop a 90-degree angle to create kind of a right triangle that we have in this bottom corner. And anytime we know two angles in a triangle, we can always find that third angle. That third angle is not hard to find. That's 67 degrees. I think if we just add up the angles that we see in the triangle, we should get 180 degrees as a total for the three angles. One thing that I note here is that 67 degrees and this other missing angle on the other side form a linear pair. So that other missing angle ought to be the supplement to 67 degrees or 113 degrees. And what we have in this picture now is a triangle on the top. I'm trying to kind of highlight that. And we're trying to find that length x, the length of that wire. So what we want to try and do is take that image and pull that image out, and then we would want to try and be able to fill in some of the missing pieces here. We got an x measurement, and then a 30-degree angle and a 113-degree angle, and then an 80-foot length. This is a non-right triangle, but we can use the law of sines now to try to find a missing side length. All we really need to do in the law of sines is recognize that the ratio of any side length divided by the sine of the opposite angle, or you can say the sine of the opposite angle divided by the opposite side length, that pairing is going to be the same ratio for the angle A and the side length A, and then the angle B and the side length B, and the angle C and the side length C. So we can take these fractions and actually flip them over also. And I think that's what I will do in this case. When I try and solve this equation, the one thing that I do is I try and get set up kind of an equation where we have just maybe two of these pieces. So I'm going to flip both of those fractions and say a over sine of a is equal to b over sine of b. So in my triangle, I'm going to try and find the side length x. So I put that on top of one of the fractions. The angle across from x is 113 degrees. So we'll put in sine of 113 degrees underneath the x. And then that ratio, that fraction, ought to be equal to a corresponding fraction of the other side length, 80, divided by sine of its opposite angle, which is 30 degrees. An algebraic trick here, I'm trying to get x by itself, so I'll just undo division by sine of 113 degrees. So I'll just multiply both sides by sine of 113 degrees. And I can come in here with a marker or a pen and just cross off those two quantities and replace them with ones. So this really becomes x times 1, or 1 times x divided by 1, is equal to all of this other stuff, which is really just a numerical value. I can then use a calculator to figure out what 80 multiplied by sine of 113 degrees, all divided by sine of 30 degrees, is. I got 147.28. I think at this point it's worth going back and looking at the question a second time and seeing that we're trying to find the length of the wire from the top of the flagpole to the point P on the hill. I found the side length x, which is exactly what I'm trying to find. So the length of the wire is about 147.3 feet. I hope this quick video helps you understand a couple of things about the law of sines and maybe just shows you how to apply that in a somewhat more complicated problem.